Hi, today we are learning about factorial. We'll see what is the definition of factorial and how can we develop the logic to find factorial for any given positive number. First of all, let's see what's a factorial. So factorial simply means product of all numbers from 1 to 1. In mathematics, the factorial of a non-negative integer n denoted by n factorial, that is n and then exclamation mark. So this is read as n factorial is the product of all positive numbers from 1 till n. For example, let's say we want to find factorial of a number 4. How we will denote it? 4 factorial, that is 4 and an exclamation, and the answer is 24. Now you must be wondering how we have got 24. Very simple. The definition says it's the product of all integer numbers from 1 till n. So start multiplying 1 followed by 2, 3, and 4. So the answer of this mathematical expression is 24. Now to simplify, in mathematics, we'll be writing as 1 into 2 into 3 into 4, and we get the answer is 24. Now when we talk about programming, we'll have to develop a logic to write this expression. All right. So let's begin. We'll open an online compiler and note down our question for today. Write a program to find factorial of a number. Let's say I have variable y and I'm storing value 4 in this. What we are looking at is 4's factorial. We are trying to find factorial of 4 and we know the answer should be 24. Some might be thinking, let's just write 1 multiplied by 2 multiplied by 3 followed by 4 and done. Correct. Mathematically, this is the correct way of getting 4's factorial, not a problem. We get 24 as an answer. All right. But what if I make this as 14 or I change this value to 19? In that case, we are not going to write an expression as 1 multiplied by 2 multiplied by 3 and so on. So that is the reason this won't be a complete program. We'll have to write a logic as in whatever is the value of y, we'll be able to find factorial of that number. All right. So let's develop the logic for this code. Now coming back over here, we see that the expression for 4 will look something like this. 1 multiplied by 2 and so on to 4. If I was supposed to find factorial of 6, the factorial of 6 is 120. Now how is that calculated? 1 multiplied by 2 multiplied by 3 multiplied by 4, 5 and 6. So that way our answer is 720. Now how we will write a code such that this multiplication keeps on happening till we have reached our number n and we finally get the output. So let's try and break this expression. As in, what I would like to do is first just multiply 1 into 2, take the result, multiply it by 3, then take the result, multiply it by 4 and so on. So in that way, I'll be first getting 1 into 2, which is 2, multiply 2 by 3, I'll get 6, multiply 6 by 4, 24, multiply 24 by 5, that's 120, and multiply 120 by 6. That's how we get 720. You can see factorial of 4 is 24, correct? When we keep on multiplying till 4. And as we move ahead, the value comes to 720 if we are trying to find 6 factorial. Now, in this way, it could be any positive number whose factorial is to be found out. That means this repetitive multiplication will keep on happening till it reaches the last value n. So keeping this in mind, let's try and write the logic over here. Okay, so considering factorial of 6, as I was saying, I'll be writing the same expressions over here in this manner. First, multiplying 1 into 2, I'll get answer as 2. Reuse the value 2. I'll multiply it by 3. I'll get the answer 6. 6, multiply it with the next number, and so on. So keep on doing this. 24 multiplied by 5 is 120. 120 multiplied by 6, and that's how we get 720. Now I have written this expressions for a reason, because by looking at this expression, we are going to write our logic. Now, if we look at this expression very well, we can see that continuously we have kept on multiplying 2, 3, 4, 5, 6. So from this mathematical expression, we have already considered numbers 2, 3, 4, 5, 6, and we got the final output 720 at the end of all the expressions. All right. Now you must be thinking, what about this one? We'll get that part as well. Now, what are we trying to check over here is, as we keep on multiplying the numbers, you just have to reuse it. Now, how do we use this self expressions and write our logic? Take a look closely. What we have done, we have just kept on multiplying the numbers by 2, 3, 4, 5, 6. And these numbers, which are in red box, have been multiplied by what? The previous product. You can see 2, which I got in step 1, has been multiplied by 3. 6 has been again reused. 24 has been again reused. 120 has been again reused. This is going on till we are reaching the value n. All right. So as soon as we have reached 6, it stops, and then we finally get the answer is 720. So if I try to write my expression, what am I trying to do? I'll try to run a loop. Why are we trying to use a loop? Can you think? Definitely you can look at the expressions and come to know that repetitive multiplication is happening. So there is one statement which keeps on repeating. That is, a number is getting multiplied and the product is reused in the next iteration. All right. So that's the reason we'll be using a loop over here. Now, when we use a loop, we have to define a loop which will run for definite time. That is for a fixed number of time. So in this also, we'll have to decide what will be the starting point, what will be the ending point, and in which variable we are going to store the result. All right, let's check that out. So let's say I'm going to run a loop from 1 to 6. So my variable I is running the loop from 1 to 6. All right, one variable is sorted. What about the variable which will store the value or which will be used over in multiplication? As I said earlier, the product of this step or this statement is reused in the next iteration. Similarly, the product 6 is reused in the next statement. So this will continue till we reach n, and that is why our factorial will be looking something like this. For example, let's say we are going to store the result in variable f. All right. So we'll multiply f with I. So what we can make out is we have a number which is getting multiplied by I, which is going to iterate from 1 to 6. And we will be storing the result in some variable. Now let's say we have decided to store the result in variable f. So here on the RHS, I have variable f. Now comes the question, what should be over here? Should it be f or should be any other variable? Now definitely you can understand over here, it should be f. Why? Because the product has to be reused in the next iteration. That means f into I is equal to f. And as you know, in Python, we assign the variables to left-hand side of the equation. That means this equation will be f is equal to f into r. Now you must be thinking why f is on both the sides. So initially, f is starting with some value. Let's say it's starting with value 1. Multiplies by 1, as we have said that I will start with 1. So f is 1, multiplying the value with variable I, that is 1, and the result is 1. The same product is carried forward to the next iteration and multiplied by 2, which gives us the result 2. Again, 2 is carried forward to the next iteration and so on. And that is the reason this will be our final equation used to find the factorial. So let's go and write the logic to test the program. All right, so we have said we will run a loop from 1 till n. In our, let's make this variable as n. And since we took an example of 6, we'll find the factorial of 6. 720. All right. So let's take a loop. I'll use a for loop for I in range. And we want our loop to start from 1. For now, I'll write n, close parenthesis, colon, enter. What are we trying to do? Let's try and just print the value of variable I. Let's run. Let's see I is iterating from 1 till 5. And as we can see, we are finding factorial of 6. That means this should go from 1 till n plus 1. That is, starting value is included, ending value will be excluded. So 1 comma 7, as in from 1 comma 7, it will include 1 and it will go on till 6, exclude 7. All right. What are we trying to do over here? We are trying to multiply the variable f by r. And as I've said, in Python, we store the values in variables on the left hand side of the equation. So here I'll be writing f is equal to f into r. That's it. That's the program. But something is missing. Let's say I would like to print the result at the end. Now, if you try to run this program just by writing just 3 lines of code, it's going to give us an error saying name f is not defined. Now, there is a golden rule. Remember, a golden rule. And what is the golden rule? Whenever a variable is written or used on both the sides, that is LHS and RHS, correct? It means it must be initialized before using it. And if you don't, it's going to give an error that f is not defined. Why? Because straight away in the first iteration, when it is trying to multiply 1 with something, and that something has not been defined in the whole program. That is the reason it gives an error. So let's say f is equal to 1. Now, if you have got the logic, you might be clear why f is 1. All right, so f is equal to 1. And let's try and print the value. You'll get 720 as an answer. So to be precise, I can print the output as f, that is 720 is factorial of 6. So we will say that n factorial is, and what is the value? Just print that. We can say that 6. Make sure you do not generate errors like this. So 6 factorial is 720. Okay. This is not looking that good, because you don't want to put a space between 6 and factorial. So in that case, I'll use another print statement. You might be thinking, if you do so, it will print factorial is 720 on the next line. Yes, but if you add a parameter end equals to, no space, end equals to double quotes, this does what? It allows to print this statement and the next statement on the same line. And after n, it won't print anything. So that's why if we run, it's there you go. 6 factorial is 720. Now, those who are wondering, what is this end equal to? Let's say I wrote here 6 factorial. Although we do not write a string or something like this, it will print 6 factorial. And you can see after L, there is no space or any other character. It's straight away printing exclamation after it. That means whatever you give in the double quotes of n, it will be printed as it is, and it will be in continuation. After this, it is not going to end the line. That is why the word end, and it will continue the next print statement on the same line as well. So 6 factorial is 720. Now, just to make this code a little more better, we can give a user input. So we can modify a question as write a program to find factorial of a user entered number. That means instead of taking 6, what we'll do, we'll ask the user to give us an input. So we'll say enter a positive integer and run. Let's put 4. It should give 24 as an answer. There you go. Now, some might be thinking, what if I do not give a positive value? What if I give negative as an answer? In that case, let's try -3. Now here we are getting -3 factorial is 1. It's basically incorrect. Why? Because factorials are found only for positive integers. Correct? Even our definition says the same thing. So the factorial of a non-negative integer. In that case, if you try to put a negative integer, it is not going to give us an output. So to make sure that you are giving a positive integer, what you can do a little validation before calculating the factorial. And to do so, what you'll do? So for validating, we can use a simple if block. We'll say if n is less than 0. Definitely if n is less than 0, we want to print a message, and that message can be something like factorial of non-negative number is not to be calculated, as you cannot calculate it. All right. Full stop. And after this, you don't want to go and print -4 factorial is 1. So in that case, we can use a very simple function called as exit, which will stop or terminate your program right away. So rather than using an if-else block where you try to put this whole thing in one of the blocks, we'll just use one simple if block. And in this case, if the number is negative, it will print this statement and exit the code. Let's try and run. We'll give a negative number, let's say -21. It says factorial of non-negative number is not to be calculated. Okay, we wrote it wrong. It should be negative, correct? So if I try to give -9, it says factorial of negative number is not to be calculated. If we rerun the program, and let's say we'll give 5, and we saw factorial of 5 is 120. That's it.